Cloud computing refers to delivering computing services such as servers, storage, databases, networking, software over the internet. Azure, being Microsoft's cloud platform, supports all types of cloud services: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. Each type offers different levels of control and flexibility, and choosing the right one depends on your application needs. Azure offers a wide range of services that cater to various workloads. Compute services such as virtual machines, VMs, and app services help run applications, while networking services like virtual networks and load balancers manage communication. Azure also offers various storage services, including blob storage for unstructured data and SQL or Cosmos DB for structured data. The platform supports both traditional and cloud-native databases, providing businesses with the flexibility to run any application. Azure operates more than 60 regions worldwide, making it one of the most geographically distributed cloud platforms. Within these regions, Azure offers availability zones, which are physically separate locations to ensure fault tolerance. If one zone experiences an outage, applications can seamlessly fail over to another zone, maintaining availability. This setup also helps Azure comply with local data regulations, allowing businesses to store data in specific regions to meet compliance requirements. Azure virtual machines offer full control over the operating system and applications running on them. You can scale VMs up or down based on demand, which is especially useful for applications with variable traffic. Azure offers a wide variety of VM sizes to meet different needs: general-purpose VMs for balanced workloads, compute-optimized VMs for CPU-intensive tasks, and memory-optimized VMs for applications that require large amounts of memory. Virtual machines are highly versatile and can be used to host enterprise-level applications such as SAP or Oracle. They are also commonly used for running development and testing environments, allowing teams to simulate production environments without investing in physical hardware. Another popular use case is extending on-premises workloads to the cloud, leveraging VMs for additional capacity during peak times. Azure Virtual Machine scale sets allow you to automatically increase or decrease the number of VMs based on demand. You can either scale horizontally by adding more VMs to distribute the load, or vertically by increasing the resources of an individual VM. To optimize traffic distribution, VMs can be paired with Azure load balancers, ensuring consistent performance even during traffic spikes. Azure VMs are often deployed within virtual networks, VNets, providing an isolated environment where resources can communicate securely. Network security groups, NSGs, allow you to control inbound and outbound traffic to your VMs, while VPN Gateway enables secure communication between on-premises networks and your Azure VMs, making hybrid cloud solutions a reality. Azure App Services is a fully managed platform for hosting web applications, RESTful APIs, and mobile app backends. It supports a variety of programming languages, including .NET, Java, Node.js, Python, and PHP, making it a highly flexible platform for developers. Continuous deployment options like integration with GitHub or Azure DevOps allow you to streamline development and deployment processes. Azure App Services is commonly used to host e-commerce websites that need to scale based on traffic. It's also an excellent choice for API backends, particularly for mobile apps that require reliable, low-latency data retrieval. Large enterprises use Azure App Services to host complex applications, taking advantage of its auto-scaling and high availability features. Azure App Services automatically scales based on traffic, ensuring your application can handle large spikes in usage. Deployment slots allow you to update your applications without downtime. New updates can be tested in a staging slot and then seamlessly swapped into production. By deploying your app across multiple regions, you can achieve high availability and ensure that users experience minimal downtime even during regional outages. Azure Storage offers a suite of storage solutions including blob, file, queue, and table storage, each designed to meet different data needs. All storage types are fully managed, highly scalable, and secure, ensuring data integrity and availability across regions. Blob storage is Azure's object storage solution designed to store large amounts of unstructured data such as images, videos, and backups. It offers multiple access tiers, hot, cool, and archive, allowing you to optimize costs based on how frequently you access the data. With built-in redundancy options like LRS and GRS, your data is always available and protected against failure. In real-world applications, blob storage is widely used for disaster recovery by storing backup data in the cloud. It's also the backbone of media streaming services where large video files are stored and accessed on demand. Additionally, it serves static content such as images and videos for web applications that need fast, scalable access. Blob storage offers multiple redundancy options. Locally redundant storage, LRS, keeps 3 copies of your data within a single data center, while geo-redundant storage, GRS, stores copies across different regions for added protection. Azure Blob Storage ensures security with encryption at rest and in transit, giving you full control over your data's accessibility and safety. Azure File Storage offers fully managed file shares that use the SMB protocol, allowing seamless access from Windows, Linux, and macOS systems. This is especially useful for lift and shift scenarios where existing file systems are migrated to the cloud with minimal changes. In enterprise environments, file storage is often used for sharing files across teams and departments. It's also ideal for storing application settings and configuration files that need to be accessed across multiple VMs. By integrating Azure Active Directory, AD, you can secure access to file shares and control permissions at a granular level. Queue storage allows for asynchronous message-based communication between different parts of an application. By storing messages temporarily, queue storage decouples application components, allowing them to operate independently. This makes it ideal for large-scale messaging workloads where multiple components need to interact without being tightly coupled. In the real world, queue storage is often used to manage order processing in e-commerce platforms where multiple services handle payments, inventory, and delivery updates. It's also ideal for handling large volumes of IoT data, ensuring that data from devices is queued and processed efficiently. Additionally, it's great for queuing tasks for background processing, such as sending email notifications or generating reports. Azure Table Storage is a NoSQL key-value storage solution that provides schemaless, semi-structured storage. It's designed for large datasets, offering a highly cost-effective solution for applications that don't require the relational structure of SQL databases. Table storage is commonly used for storing user data, logs, and other structured or semi-structured data. Table storage supports horizontal scaling, meaning it can handle vast amounts of data without affecting performance. It offers high throughput for read and write operations, ensuring that your data can be accessed quickly even as it scales. This makes it perfect for real-time data access where latency needs to be kept to a minimum. Azure Virtual Networks, VNets, allow you to isolate and segment your cloud workloads, providing greater control over network traffic. You can define multiple subnets within a VNet, each representing different parts of your application, such as front-end, database, or back-end services. VNets also give you control over IP address ranges, ensuring that network segmentation is customized to your needs. VNet peering allows you to connect 2 or more virtual networks, enabling low latency, high bandwidth communication between them. This is especially useful for organizations that manage multiple VNets across different regions. With cross-region VNet peering, you can connect resources in different regions seamlessly without having to route traffic through an external network. Network security groups, NSGs, allow you to apply security rules to subnets or individual VMs, controlling inbound and outbound traffic. These rules help you allow or deny specific traffic based on IP addresses, ports, or protocols. NSGs can also be used alongside Azure Firewall, providing an extra layer of security by inspecting and filtering traffic between VNets. Azure Load Balancer efficiently distributes incoming traffic across multiple instances of your application, ensuring no single instance is overloaded. It supports both public and internal load balancing, allowing you to manage both internet-facing and internal services. The load balancer automatically scales with demand, ensuring your application can handle traffic spikes seamlessly. Azure Application Gateway is a web traffic load balancer that operates at layer 7, allowing you to route traffic based on application level information such as URLs or host headers. It supports SSL offloading, where SSL termination is handled by the gateway, reducing the load on your backend services. You can also configure end-to-end SSL for additional security, ensuring encrypted traffic all the way to the application. Azure SQL Database is a fully managed relational database service that offers automatic patching, backups, and scalability. With built-in high availability, it ensures your data is always accessible even during maintenance or unplanned downtime. It's ideal for applications that need a highly available, fully managed database solution. SQL Elastic Pools allow you to pool resources across multiple databases, ensuring that they share a common set of resources. This is particularly useful for managing variable workloads where some databases may experience higher demand than others. Elastic pools help optimize costs by automatically scaling resources to match the usage patterns of each database. Azure Cosmos DB is a globally distributed NoSQL database designed to offer low latency access to data across multiple regions. It supports multiple consistency models, allowing you to choose the right balance between performance and data consistency. Cosmos DB is highly versatile, supporting key value, graph, and document data, making it ideal for a variety of applications. Cosmos DB is commonly used in real-time IoT applications, where data needs to be accessed from different regions with low latency. It's also a great fit for applications with global user bases, as it provides consistent, low-latency reads and writes regardless of where the user is located. Its flexible schema makes it ideal for applications that evolve over time and require rapid development. Cosmos DB offers multiple consistency levels, ranging from strong consistency, which ensures the most up-to-date data but at the cost of performance, to eventual consistency, which offers higher performance but allows for some data lag. Bounded staleness and session consistency provide a middle ground, allowing you to choose the level of consistency that best fits your application's needs. Serverless computing allows developers to focus on writing code without worrying about the underlying infrastructure. It follows an event-driven architecture where your code is executed only when certain events trigger it. Serverless solutions like Azure Functions scale automatically based on demand, making them highly cost-efficient as you only pay for the compute you use. Azure Functions is Microsoft's serverless compute solution that allows you to run code in response to events like HTTP requests, timer triggers, or message queues. It supports a range of programming languages including C#, JavaScript, Python, and PowerShell, making it versatile. Azure Functions are ideal for microservices architecture, where lightweight, decoupled services interact to form complex applications. In real-world applications, Azure Functions can be used for event-driven data processing, such as analyzing data from IoT devices in real time. It's also widely used for automated file processing tasks, such as generating PDFs or resizing images upon file upload. Another common use case is real-time stream processing, where Azure Functions can process social media data streams to provide insights instantly. Durable functions extend Azure Functions by enabling stateful workflows. This means you can orchestrate complex workflows that require multiple steps, each triggered by different events. Built-in patterns like fan-out and fan-in allow you to process tasks in parallel, then aggregate the results. Durable functions also handle retries and compensation logic, making it easier to build robust workflows. Azure Logic Apps offer a low-code solution for automating workflows across both cloud and on-premises services. With hundreds of pre-built connectors for services like Office 365, Salesforce, and Dropbox, you can automate complex processes with minimal coding. Logic apps provide an intuitive interface for building workflows, making them accessible to both developers and non-technical users. Logic apps are commonly used to automate approval processes such as HR workflows that involve multi-level approvals. They can also monitor data changes in systems like CRM platforms and trigger actions when specific conditions are met. Logic apps integrate seamlessly with Azure services, enabling you to build sophisticated workflows that connect databases, APIs, and event-driven functions. To optimize logic apps for performance and cost, it's important to choose the appropriate trigger types for your workflows. For example, polling triggers can lead to unnecessary executions if not configured correctly. Monitoring usage and setting up thresholds for triggering workflows can help prevent overuse. Additionally, using connectors efficiently by consolidating API calls can significantly reduce costs. For optimal performance, it's best to keep Azure functions stateless, so they can start and run quickly without needing to maintain any persistent data. Use Azure Monitor to track performance metrics such as execution times, memory usage, and success rates. To optimize cold start times, consider deploying functions in the premium plan or use pre-warmed instances to reduce latency. Azure Monitor provides end-to-end monitoring for applications, infrastructure, and networks. It collects logs, metrics, and traces from all your Azure resources, giving you a holistic view of performance. Azure Monitor integrates seamlessly with alerts and dashboards, enabling real-time monitoring and proactive management. Azure Monitor integrates with log analytics, allowing you to query logs and find specific events across your infrastructure. Application Insights provides deep insights into application performance, identifying bottlenecks, exceptions, and slow response times. Together, these tools help you detect issues before they impact users and optimize your applications for better performance. Alerts are a critical component of Azure Monitor, allowing you to define threshold-based triggers for specific metrics. For example, you can set up an alert to notify you when CPU usage exceeds a certain level. You can configure notifications through email, SMS, or webhooks to ensure that your team is aware of potential issues. Additionally, automated responses can be set up to resolve common issues immediately. Azure Security Center provides continuous security monitoring for your Azure resources. It automatically analyzes your environment for security risks and provides recommendations to help secure your infrastructure. Security Center integrates with compliance tools, making it easier to meet industry-specific regulations like GDPR or HIPAA. With Azure Security Center, you can detect potential attacks and suspicious activities in real time. It leverages advanced analytics to identify threats and offers just-in-time VM access, which limits access to virtual machines only when necessary, reducing the attack surface. Additionally, enabling vulnerability assessments on critical resources helps identify and resolve security gaps before they're exploited. Azure Sentinel is a cloud-native security information and event management (SIEM) solution that centralizes security logs and events. It uses artificial intelligence to detect advanced threats across your environment. Sentinel also allows you to automate incident response workflows, ensuring that critical security incidents are investigated and resolved as quickly as possible. Azure Cost Management helps you control cloud expenses by tracking resource usage and spending across your entire environment. You can set up budgets to ensure you don't exceed your planned expenditures and monitor real-time cost and usage metrics to gain better visibility into where your resources are being consumed. Cost analysis in Azure allows you to visualize spending trends over time, helping you identify spikes or anomalies that might indicate over-provisioning or inefficiencies. You can also allocate costs to specific departments or projects, ensuring that each team is accountable for its cloud usage. To optimize costs, consider using reserved instances for predictable workloads, as they provide significant discounts compared to pay-as-you-go pricing. Additionally, ensure that auto-scaling is configured correctly to match demand, preventing over-provisioning. For non-critical tasks, such as batch processing, spot instances offer lower-cost compute resources. Azure Backup provides an automated data protection strategy for virtual machines, SQL databases, and files. It supports long-term retention, making it easier to meet compliance requirements. With centralized backup management, you can monitor and manage backups across your entire environment from a single dashboard. Azure Backup uses incremental backups to reduce storage costs by only backing up changes since the last backup. It also offers full backups for complete recovery points. With granular recovery options, you can restore entire systems or individual files as needed. Azure Backup helps protect against ransomware attacks by keeping backups secure and ensuring they can't be tampered with. Azure Site Recovery allows you to replicate workloads to secondary regions, ensuring that critical applications remain available during a disaster. Automated failover and failback processes minimize downtime, while real-time replication keeps your secondary region in sync with the primary site. This makes Azure Site Recovery an essential component of your business continuity strategy. Azure provides a rich ecosystem for artificial intelligence (AI) and machine learning (ML), allowing organizations to build intelligent applications at scale. Whether you're training custom models or using pre-built services for image recognition, speech synthesis, or natural language processing, Azure makes it easy to bring AI into production. Azure Machine Learning Studio provides a comprehensive environment for building, training, and deploying machine learning models. By adopting MLOps, you can automate machine learning workflows and streamline the deployment of models into production environments. Notebooks, such as Jupyter, allow for experimentation and collaboration, making it easier for data scientists to work together. Azure Cognitive Services offer pre-built AI models that allow developers to integrate advanced functionality into their applications quickly. The Vision API provides powerful image and video analysis, while speech-to-text and text-to-speech services enable speech recognition and synthesis. Language understanding models power chatbots and virtual assistants, allowing for more natural interactions with users. In the real world, Azure AI is used for a wide range of applications. In financial services, AI models are used to detect fraud by analyzing transaction patterns in real time. E-commerce platforms leverage Azure's AI services to provide personalized recommendations based on user behavior. In manufacturing, predictive maintenance models help prevent equipment failures by predicting when maintenance is needed. Azure IoT enables you to securely connect and manage IoT devices at scale. From smart factories to connected cities, Azure IoT allows you to gather real-time data from edge devices and analyze it in the cloud. Azure IoT Hub provides the infrastructure to manage millions of devices, ensuring reliable communication and data collection. Azure IoT Edge extends the power of cloud intelligence to edge devices. By deploying AI models at the edge, organizations can process data locally, reducing latency and improving real-time decision-making. This is especially useful in scenarios where connectivity to the cloud is intermittent or where real-time processing is critical, such as in autonomous vehicles or industrial robotics. Azure IoT is being used in a variety of industries. In smart cities, IoT sensors monitor traffic flow and optimize energy consumption. In healthcare, IoT devices enable remote monitoring of patients' vitals, allowing for more proactive care. In agriculture, IoT sensors monitor soil quality and weather conditions, helping farmers optimize their operations and increase the crop yields. Azure Blockchain provides the tools needed to build decentralized applications, or dApps, and create secure, immutable records of transactions. Blockchain is widely used in industries like supply chain management, where it ensures the provenance of goods, and in finance, where it supports secure digital contracts. It is also gaining traction in healthcare for secure patient data management. In this chapter, we'll review key compute services covered in the course. Azure Virtual Machines provide fully customizable compute environments, allowing you to install and run any application. App Services is a fully managed platform for hosting web applications and APIs without worrying about infrastructure management. Finally, Azure Kubernetes Service, AKS, provides container orchestration for deploying and managing containerized applications at scale. In Azure Storage, we covered several core services. Blob storage is used for unstructured data, such as images and videos. File storage provides managed SMB file shares, while disk storage is designed for persistent storage to be used with virtual machines. These storage options offer scalability and redundancy to ensure your data is protected and available. Networking is a critical part of Azure's infrastructure. Virtual networks allow you to create isolated network environments for your resources. Network security groups, NSGs, and Azure firewalls help control inbound and outbound traffic, ensuring your applications are secure. Load balancers distribute traffic across multiple instances to maintain high availability and reliability. In serverless computing, Azure functions allow you to run code in response to events without managing infrastructure. Logic apps provide a low-code way to automate workflows across multiple services, both in the cloud and on-premises. For more complex workflows, durable functions enable you to orchestrate multiple function executions while maintaining state between them. Security is paramount in the cloud, and Azure provides robust tools for maintaining a secure environment. Azure Security Center monitors your resources for vulnerabilities and threats, while Azure Sentinel acts as a cloud-native SIEM solution for detecting advanced threats. Following best practices like the principle of least privilege and encrypting data at rest and in transit ensures your applications are as secure as possible. Congratulations on completing this Azure Fundamentals course. You've built a strong foundation in Azure services from compute and networking to security and serverless. With the knowledge you've gained, you're now ready to take your understanding further and start applying it in real-world scenarios. You're now ready to tackle the Azure Fundamentals Exam. Take some time to review the core concepts we've covered throughout this course. Practice exams are a great way to test your knowledge and familiarize yourself with the format of the exam. Continue exploring the Azure portal to reinforce what you've learned, and you'll be well prepared to pass the exam. As you prepare to take the exam, remember to stay calm and read each question carefully. The knowledge you've built during this course will help you approach each scenario with confidence. Good luck, and thank you for joining me on this journey to mastering the Azure fundamentals.